So let's continue. Okay? There's only 2 more paragraphs, so be patient. I know. Okay? Here you go. This is a pretty long one, right? While the sun is a near perfect sphere and appears to be naked to the naked eye, as a precise and sharply defined yellow circle against the sky, and has its ancient astronomical symbol of the circle with the point at its center, the sun does not actually have a defined edge or boundary. Instead, the density of its gases decreases especially with... Okay, I'm not going to read this, okay? So what I'm going to do is, basically, I'm going to ask you guys to read this whole thing, okay? I'm going to give you a few minutes, okay? And while I'm giving you guys a few minutes, okay, I'm going to talk to you, okay? Because, I call it, it's kind of pointless for standing here, okay? And second thing is, when you're doing this, I'm going to remind you, you don't take this note-taking at the very end when you get to this question. You're doing this anyways during the other question, which is what? Factual, negative factual, right? Purpose, right? Inference, right? These are the questions that you guys are already taking notes in each paragraph, right? We have to take notes in this section. The reason why is because I'm showing you guys how to do it. Okay? So try to take notes. Okay? Look at each sentence. Okay? Try to look at 2 sentences at one time and try to skim it in your head and go, okay, I need to get the points up. Okay? How many guys find these difficult? It's just because it's long, right? Okay. Skim through your eyes. Skim through information you don't need. Okay. First of all, you can skim through like brackets. Get rid of the worst thing, right? Like numbers like 100 kilometers thick. Okay, you don't need those things, right? Okay, let's continue. Okay, here we go. Boom. Okay, now the first sentence basically talks about what? It's a near perfect sphere? No, because it is what? No edge boundaries. That's what it says, right? Okay, and heat and energy is called nuclear fusion. Okay, the next thing that I'm talking about is the energy must travel through a number of different layers. Okay, what type of layers? First one is what? Photosphere, right? It's the first layer. Okay, what is photosphere? It's thin and it has the outer layer. It's called what? Corona. Okay, which is what? Corona's what? It's about what? It's really thin. Okay, we don't have to put the numbers. 100 kilometers thick. Okay, and then what the last part here? What does it say? Over there, sorry. Heating and maintaining, unsolved mystery. Okay, so we don't know much about the sun because it's too hot. Okay. That's your notes. Okay, let's look at the next one, okay? This is pretty big, so I'm going to step back a little bit. Ready, set, go. Boom. Okay. Now this one, I want you to take notes in the same manner, okay? Okay. I want to see you guys try it, okay? And I'm going to go over it with you guys together. I'm going to give you a few seconds, okay? Now, another solar system is solar mystery is the curious nature of solar flares. Okay, equivalent to 1,100,000 megaton hydrogen bomb detonated simultaneously. Solar flares are the most intense and energetic explosions that occur in the solar system. These explosions occur on the sun's photosphere and are difficult to view through layers bright emission. Okay. Even with specialized equipment, solar flares are directly linked to another more easily observable solar phenomenal sunspots. Okay, with the invention of the telescope in 1608, astronomers were finally able to look into a face of the sun and see that it is not a perfect and unchanging yellow disk as they had expected, but that it is often mirrored by several blemishes or dark spots. Okay, so basically dark spots. Okay, these dark areas are the coolest regions of the sun's photosphere and are characterized by intense magnetic activity. The frequency of the sunspots occurrences follows an 11-year solar or sunspot cycle. At the minimum end of the cycle, there is very little sunspot activity, and at the maximum end, there might be hundreds of visible sunspots. An increased number of sunspots indicate a correlated increase in solar flare activity. This period of activity can pose a serious danger to satellites and astronauts. One solar flare can emit enough magnetic energy to cause a serious damage to a satellite or change the satellite's orbit, okay, resulting in blackouts over large areas. Now, because of these dangers and our increased reliance on solar satellites, it has become even more important for scientists to understand the nature of solar weather and to determine more accurate method of predicting solar activity. Okay? You're like, wow, teacher, so big. Right? It's true. Okay? Okay, let's skip. Let's check out your notes. Ready? Boom. Here you go. Okay? Another solar mystery is the solar flare. So the main idea is what, everyone? Solar flare. Okay? Boom. Okay? Okay? I want to talk about solar flare. Okay? The 100 million telescope we don't care about. Flares R is safe is equal to, right? Intense energy explosions. So basically solar flare is defined as intense energy explosions, okay? Then, second thing is, it's hard to view the next sentence, right? Why? Because it's hard to view, right? We don't have to give details, just get the main point. Main point is hard to view. You don't have to tell me because of special equipment, okay? The next sentence over here, it says it's linked. Okay, to even what? A phenomenon called sunspot. Okay, what is a sunspot? It's basically blemishes, dark spots, right? Coolest region, okay? And it has many magnetic activity, okay? Okay. It emits magnetic energy, okay? And this energy is very dangerous, okay? We don't care who, it's just dangerous. And this is called solar weather, and we need to predict the solaria, which is solar weather. Okay. Now we put it all together, it kind of now looks like this, right? So you can actually look at it, okay? So now you guys know, okay, now that's what it looks like, okay? Yeah, the first one says solar layers, okay? This is solar activity, okay? Then you have the 2, 4, 6, 7 different type of ones you can put in. So 2 of them are not going to fit. Okay. So let's take a look. Okay, next page. Okay, here we go. This is mine, not the real test, but we need it for our test purposes. Okay. So what we're going to do is we're going to take a look at this. This is the type of question. It's a little easier to look at. Okay. Now we're going to take all your notes and put it and combine it together. Okay. Okay. So we're going to combine your 4 paragraphs. Here we go. Boom. 1 is over there, 2 goes below, 3rd one, and the 4th one. Got it? Okay. And we're going to basically find out which one is which. Okay. So we're going to look at basically solar layers. Where are the solar layers information talking about? Got it, right there. So you're going to forget the first one, you're going to forget the second one. You're going to go to the middle one, okay? Which is now you guys can find the word layers, okay? Now in the layers, what vocab, or which one are you going to find here? Photosphere and corona, right? So we put it in here, okay? Then, okay, so which one do you have? We can cross out photosphere It's there, right? Okay. Okay. Other thing is, just look at the next word over here. Okay, we have equilibrium. Where does that say? Where do you find equilibrium? It's actually in the first one over there, right? Which doesn't mention any. The solar one is over here, but and then the layers over there. The first two are not talking about it, so we got rid of it. So we need to cross that out. So it's gone. Okay. How about solar winds? Did it ever mention solar winds? Where does it say solar winds? Take a look at all your notes. Your notes don't mention solar winds, so boom, it's gone. Okay? Okay. Let's take a next one. Corolla. Okay? We found it. It's in the middle. It's here, right there, right? It says corona, outermost layer. So that goes where, everyone? Solar layer. Okay. Now, sunspot. Do you see sunspots? Yes, you do. Sunspots are dark spots, right? Which is actually in the solar flares. So we're going to put it up there. Great. Okay. And solar flares are from what? Solar flares. We're going to put it up in solar activity. Okay. And magnetic emission. Did I say magnetic emits magnetic energy is the same thing? So we're going to put that up there. Okay. Now, do you realize that when you're taking notes on your paper, it does look like these notes, right? Just don't forget to number the paragraphs, right? And in your notes, you should have this information. Then it becomes really easy. So then it would look like this: solar layer, photosphere, corona, sunspots, solar flare, magnetic emission, and these ones you've already used. Okay? And that's how you do the actual summarization. Okay? Thank you.